The cart of mass 10 kilograms shown below, or over here, is moving to the right without frictional force on a level table. A 10 Newton force pulls on the cart horizontally to the right. At the same time, a 30 Newton force at an angle of 60 degrees above the horizontal pulls the cart to the left. Describe a manner in which this cart could be moving. So, first, I think we can determine whether or not the cart is going to move vertically from this 30 Newton force. So now if we look at this part, we can decompose it. And the weight of the cart is simply 10 times the force of gravity, which is equal to 98 newtons. Now the force that is pulling on is 30 times the sine of 60 degrees, since the vertical component is opposite of the hypotenuse. And then this evaluates to about 26 newtons, somewhere around this. But this is not enough to pull it down. So since 26 newtons is less than 98 newtons. So it is not going to, the cart is not going to be moving vertically. The vertical force is not enough to support its weight. So we can say that our cart is not going to be moving vertically at all. So we can ignore that part. Now we need to figure out the horizontal motion. So this force to the left is going to oppose the force to the right, the 10 Newton force to the right. So we can figure out the force to the left first. And you use more trigonometry here. It's just 30. This time is the cosine of 60 degrees, since it's that force is the horizontal component is adjacent to the hypotenuse. And then this is just simply 30 times 1/2. And this is just equal to 15 newtons. Now this 15 newtons is to the left. Alright, so this 15 newtons is to the left. And then you're pulling on it to the right with another 10 newtons. So your net force will be these two, 15 minus 10 newtons, or 5 newtons to the left. So this will be 5 newtons to the left. Once again, the force to the right gets canceled out, and the cart ends up accelerating to the left. Now this will cause an acceleration in the car to go to the left. But since it's initially moving to the right, it's just going to slow it down. So the cart is going to slow down, since it's the acceleration is going the opposite way as the velocity. It's going to stop, and then it's going to start moving to the right. Or sorry, to the left. Start moving to the left. And that is a description of this cart's motion.